Join discord.gg/flatearth and enter a check-in room. Someone will come along and verify you to get involved in the conversation about our Earth.
Yeah, we got some new people in here also. We got ShogunJS. ShogunJS is in here. I'm gonna mute Shogun. Shogun, if you're here,
Shotgun.
we like to hear you, Shogun.
Oh, sorry. I'm good. I'm just,
You're good.
Yeah.
Yeah, but this. Yeah, I don't know how you're good, but that's great that you're good. But anyway, welcome to the server, and we'd like for a little bit of introductory. So, as you clicked on the link and you joined here, what link did you click on, or who gave you the link, or how did you find us, and what is your position on the topic of the server?
My friends just invited me, I guess, to listen, and like a couple of days ago.
Sure. Who are your friends? Do we know them or?
No. I think they're just some random guys that just joined. I don't know how.
They gave you the link to this server? Okay.
Yeah.
That's cool. And so, what is your position on the topic of this server? The conversation of the shape of the Earth.
What's the topic? I'm a round earther, I guess. Yeah.
You're a round earther?
Yeah.
Okay, so when you say round earther, do you know what that means?
No.
Yeah. You don't know what round. The term round, do you think that it only refers to one specific thing, or can it mean something else?
It probably means a lot, like round probably could mean flat as well, but yeah.
Okay. So round could mean round and flat, right? So what would you define what you say that you think the Earth is?
Well, I probably think that the Earth is not flat, but I mean.
How would you? Well, what's the right word to say then, other than round?
Probably a sphere, maybe.
Sphere. Okay, maybe. All right. So, would you say that you know that to be 100% sure that you know that it's a globe and a sphere, or is this something that you just don't really know for sure?
I mean, just my observations, I would say, I believe that it's a sphere.
But you don't know it, right? You just believe it?
Yeah.
Okay. So I'll let somebody else take over the conversation. I will go a little bit farther with you, but just for your introduction, thank you very much for that. I'll see if I'll kick it over to Jedi, see if he wants to have a convo with you.
Hello, mate. You can start from Australia or New Zealand.
Oh, sorry.
Shogun. Where are you from? Australia or New Zealand?
New Zealand.
Ah, awesome stuff, man. Well, welcome to our server, my friend. What sort of age range are you? Under 20? Are you in your 20s?
I'm in my 20s.
Ah, awesome stuff. And you completed high school and normal type of education and got taught like everybody else that the Earth is a spinning ball in a vacuum of space, yeah?
Yep.
Awesome. And like you told Mayhem, you kind of just believe that, right? You understand that a belief is not knowing, not knowledge. Yeah?
Yeah, I do.
Awesome. So it's just a belief that you've got along with everybody else. How do you observe the world, my friend? Do you, for example, feel the Earth moving, as we are told that it is?
No, I don't feel it's moving, but I mean, I guess... yeah.
You guess? No, that's fine. What do you guess?
Sorry, what do you mean by guess? Like...
What were you going to say? You said no, but I guess.
I don't know. Yeah.
Yeah, but the Earth doesn't look like it's moving either, does it? Like, it's not acting like it would do if it was a moving object. The water, for example, that isn't.
I'm sorry.
Go on.
I'm sorry. He said he observed the Earth as a sphere.
When did he do that?
I was waiting for that. When did you look and see it was a sphere?
Like my observations, like, like when I look over the horizon, like, it's, it kind of doesn't plateau. It just.
When you look over the horizon, can you get a picture of that?
Like,
what do you mean?
Like when you look over, like if I look in like towards Australia, I can't see Australia. when I'm on the beach.
No shit, it's too far away for you to see, right?
Yeah, right. I don't know.
Well, yeah. I mean, you understand that things with distance, the further away they are, they get smaller and eventually become too far away for you to see. Maybe Australia from New Zealand is a little bit too far for you to see, mate.
Do you know what that is? If you can't see, what happens when it gets that far? Do you know what that's called? What does that reach? Like beyond your angular resolution.
Yeah.
I dub a new fallacy called the 5 cooks fallacy. Continue.
I'm just trying to figure out how he's seen a sphere. All I heard is he looked over the horizon and then that stopped. And then he said that he can't see Australia from New Zealand. What does that, how does that equal then globe?
I don't know. I don't really research the stuff, I'll be honest with you.
Let's ask this question. What do you think the horizon is?
You know, like,
Would you maybe describe it as the crest of a hill, and the other side of it, things go down, and if you're observing, you wouldn't be able to see it because there'll be a curve in the way, something like that. Yeah. That's what we all got taught. We were told that the horizon is physical, and when things are beyond it, you can't see them anymore. All right. Have you got access to the live stream voice text? Mayhem, has he got voice verified?
I don't.
I just gave it to him. Yeah. Also, before we continue, I'm gonna pause for just a moment. Stay right here with this content. I'm gonna unmute a few guys that are just joining our server real quick, just to introduce them. We got Joanyo, whatever your name is. Are you there? Joe. I'll just call you Joe.
Yale.
Is that how you say that? Yale, are you there? Say hello. All right, if you want to say anything, go ahead and contact us later. But right now, I'm just gonna mute you just in case you want to say obscenities. All right, so you're muted. Let's see who else we got in here. Just real quick before you guys continue. That was it. There was somebody else that was in here, but I just wanted to see if he wanted to speak. That way we can get more people in the convo. All right, please continue, guys.
Shogun, you still with me, my friend?
Yeah, I'm still here.
Awesome, and you've got access to the live stream voice text. The text room just above this chat room. You can go in there for me, yeah? You can
which one? Yeah, I see. I think, yeah.
Yeah. I posted it just a few moments ago, 10 minutes past the hour. Picture with 2 oil rigs in it. Can you tell me when you see it?
Oh, yeah, I see it.
Awesome. And just keep that in your view, buddy. We're going to talk about that. Because you mentioned that the horizon's, physical, as in things beyond it are physically blocked by that curve of Earth. Yeah?
Yeah.
Yeah, okay. That's not a problem. Would you agree that if we can do some maths, we can figure out for an observer standing at altitude how far away the horizon should be? If we say know the size of the ball.
Yeah.
Yeah. So if we know the size of the Earth is a sphere, or 3,959 miles in radius, okay, and we know our observer height, it's just a mathematical calculation to figure out where the horizon is. That mathematical calculation, try and stay with me, mate, 1.2 times the square root of the observer's height in feet. I'll try and break that down for you. Start with the end bit, observer's height in feet. Now, we want the square root of that, but ultimately, our height above the surface of the Earth, we then take the square root of that and then times it by 1.225. So, to keep the math really simple, for an observer, say, at 1 foot above the surface of the Earth, we understand that the square root of 1 is 1, and we just have to multiply 1 times 1.225. So the observation of a geometric horizon should be at 1.225 miles away. Would you at least agree that if maths exists, which it does, and we can use mathematical formulas, and we can use this one, that we're going to trust this for now, yeah? This is just the maths associated with a sphere.
Yeah.
Awesome stuff. So remember, if we're making an observation at 1 foot, the horizon, if it was physical, must be 1.225 miles away. Now I'm going to draw your attention to the observation of those 2 oil rigs. Now, this is a still shot. It's a still shot from a video. We can provide you with the video later on for you if you want to. It's not a problem at all. But just to keep it short as we can, we're just going to take a look at the photograph. It's got 2 oil rigs in it. The reason why those oil rigs are there, and the only reason why they're there, is for distance markers. One's at 6 miles plus, one's at 9 miles plus. They're from the observer standing at the beach who set up his camera at 1 foot above the surface of the water. Now, he's gained his location using Google Maps, and these are static oil rigs. They ain't fucking going anywhere. We know the distance to them. Can you tell me, my friend, in reference to those 2 oil rigs, where the horizon appears to be? For example, does the horizon appear before the oil rigs, between the oil rigs, or beyond the 2 oil rigs? Where's the horizon, my friend?
Probably.
beyond the 2 oil rigs, yeah?
Yeah, probably.
Yeah, probably. We can safely say that it's at least 10 miles away. The horizon could be further, could be 15, could be 20, don't know, but it's at least 10, yeah?
Yeah.
Now, if we're on a curved surface of a sphere, and that radius was 3,959 miles, for the observer standing at 1 foot or place his camera at 1 foot above the surface of the water, the horizon must be, in this image, 1.2 miles away. The horizon is clearly beyond the second oil rig, and we can safely say it's at least 10 miles away, demonstrating the horizon isn't physical. When we provide you with the video, you'll notice that before the man zooms in with his camera, you just see the fucking horizon. You don't see anything else. Then he zooms in, then the horizon keeps on going, and then the oil rigs hone into view. So you can look at that at your leisure. But what we're demonstrating is the horizon isn't physical, my friend. It's an optical phenomena dependent on the optics that you use, your eyes, binoculars, telescope, or high zoom camera, and the atmosphere that you're looking through, affect the limitation of your view, not the physical geometric curvature of the Earth, like we were told and like you were led to believe. Do you understand that?
Yeah.
Okay. Now, you'll also notice that the water between the camera and the horizon is level. We understand that the water where it is contained, like your coffee in the morning or your bath that you have in the morning, or the swimming pool that you swim in, or the lake you go fishing in, or indeed this water between this observation and the fucking horizon is level. Now, they tell us that if the Earth, as the Earth is a ball, 70% of it is water, and that is curved water. But we're demonstrating to you that the water is indeed level. If 70% of the Earth's surface is level water, how the fuck can it be a ball? We're just talking about water and observation across it, and demonstrating the horizon that should be blocking shit isn't physical. Do you understand that, mate?
Yeah.
Yeah, seems quite simple, really, doesn't it?
Yep.
Yeah, it does. I mean, we don't see any curved water anywhere, do we? We definitely don't see any physical obstruction in this observation, now, do we?
Yeah.
So when we talk about, say, seeing from New Zealand to Australia, you got to understand, mate, it's just too far away for you to see. 3,000 miles, even with a high-powered telescope, you've got 3,000 miles of atmosphere to look through. Yeah, that's going to cause some problems, my friend. But ultimately, you can only see as far as you can. So we don't feel or detect or notice any motion to the Earth, and we most definitely don't see bendy, curved water anywhere. So that's taken care of the Earth not being a ball and the Earth not going anywhere, right? You know that place up in the sky, the vacuum of space, you know that's not true as well, right? Do you want to know why?
Oh, why is that?
Because they tell us that that's a vacuum and we're breathing gas pressure. And to have gas pressure, you must have a container, like within a football or a tyre, right? When that air is compressed within that contained volume, that gas is under pressure. If you don't have a container, and outside of that container is a much lower pressure, then according to natural law, second law of thermodynamics and entropy, the gas will increase into the space. The high pressure system will disperse into the lower pressure environment. The problem with the heliocentric model is they say the Earth is uncontained, an open system. So there's nothing physical for the gas to press upon to give us the consequent of pressure. And as there's no physical barrier, then we wouldn't have gas here. The gas would disperse into the vacuum of space, wouldn't it?
Yeah.
Yeah. So there's no ball because we can't see it. There's no motion because we can't feel it. And all of the evidence they say comes from the vacuum of space where they've turned around to take a picture of the Earth to present us with a ball that moves can't be true because that place up there can't be real. You can't have gas pressure without a container. You most definitely can't have an open system with pressure in it within a vacuum. You know Jupiter, giant ball of gas?
Yes.
Imagine that like a giant ball of gas in a vacuum without the container around it, without the football, for example. Now, you understand that if you were to click your fingers and magic that football away, the gas would fill the space. We understand that gas disperses in all directions. It doesn't correlate, it doesn't coalesce, come together and start sticking. No, gas disperses in all directions and fills the limitation of its volume. If they declare the Earth to be an open system, me and you wouldn't be breathing right now. So although flat earthers, or it seems a little bit silly, actually it's the observable, practical reality in which we inhabit. The Earth is flat, the Earth is stationary, and we're breathing gas pressure, so I don't know what to tell you about that vacuum they keep talking about, but that can't be real.
Wait, how come Jupiter and all that around though? Like, and why is Earth excluded?
I don't know. Why are trees green and why do monkeys eat nuts, mate? Things can be different, right?
I guess.
Things can be different. Those things up there most definitely don't have to be the thing that I'm standing on down here. I'm not standing on a cloud. Just because I can see a cloud doesn't mean the Earth is shaped like a cloud. Do you understand how silly that seems when I start pointing at everything saying that's where I am?
Mm.
Do you know what a triangle is?
Yeah, I do know what a triangle is.
Do you know what celestial navigation is, or have you ever heard of it? Navigating with the stars.
Yeah.
Awesome. Do you understand that if you're on a curved surface, for example, and you were trying to make a triangle, you wouldn't be able to measure an angle? For example, if I was to give you a triangle and one of those lines was curved on it, you wouldn't be able to read, well, two angles, right? Yes, no, maybe so. Yeah. So you know what a protractor is? You use them in the high school. You place them down on two lines and they meet at a vertices and you read the angle 90 degrees, 45 degrees between them. If one of those lines is curved, you're not going to be measuring an angle. Probably question 6 or 7 on your geometry test. Yeah, can you measure this angle? No, the line's curved. Yeah. So when we use celestial navigation, what we basically do is we get elevation angles off of the floor up to a star. Let's call it Polaris, for example. We draw a line down from Polaris to the surface of the Earth and create 90 degrees there, its ground position. There is then a straight line from that ground position to you. You can then get an elevation angle up to that star. You've basically built a triangle, yeah?
Yeah.
If the Earth was curved, that baseline would be bent. You wouldn't be able to measure the angle, the elevation angle up to the star, and you wouldn't be able to have 90 degrees under that star. In actual fact, you can't have 90 degrees on a curved surface, can you?
Yeah.
Yeah, no, you can't. So you must understand that every single star in the night sky has a ground position of Earth, and that ground position is at 90 degrees to whichever observer is making the observation elevation angle to a star. He can take an elevation angle to every single fucking star if he wants to, and every single star will have a 90 degrees ground position straight line to him with his sextant angle measuring device. If the Earth was curved, we would not be able to use this form of navigation. We wouldn't be using angle measuring devices because you wouldn't be able to measure an angle if one of those lines was curved. I say angle, there's at least two. One line, two angles. So being as we've used celestial navigation since, I don't know, the late 1700s, then we navigate practically the Earth to be a flat plane. It is necessary, the Earth to be flat, for us to use these devices. Do you understand that?
Yeah.
Awesome. So the Earth is observed, measured, and practically used as a flat stationary plane. Yeah?
Yep.
Welcome to Flat Earth, my friend. Any other comments, questions, concerns? There's lots of other people in the live stream that I'm sure will be willing to answer any other questions. I'll give it back to everybody else because I've spoken for far too long. I'm going to make some coffee. But I appreciate your time, my friend. I hope at least you've learned something there. And if you haven't, please ask up some follow-up questions. Nice meeting you, my friend.
Nice to meet you too.
That was an excellent presentation on elevation angle and triangles and how it doesn't work on a ball. So thank you. I took notes. Thank you.
Yeah, someone must have cut that out.
Is the live stream up? Last I saw, it was down.
Tags! What is your profession? See, old friend, I brought more soldiers than you did.